Problem 25 asks us to graph the equation 6x minus 3y is equal to 36. In order to graph a linear equation, we need to have at least 2 points to connect. The simplest points to find are the intercepts, the x-intercept and the y-intercept. We'll start by finding the x-intercept, and that's the x value when y is equal to 0. So we'll take our rule and plug in 0 for y. Negative 3 times 0 is just 0, so that turns our equation into 6x is equal to 36. We would divide both sides by 6, and that gives us a result of x equals 6. So that's our x-intercept. We can graph that point on our grid. Now we'll find the y-intercept when x is equal to 0. So again, we'll rewrite the rule, but this time we'll plug in 0 for x. 6 times 0 is 0, and so that gets rid of that part of the rule and leaves us with negative 3y is equal to 36. Divide both sides by negative 3, and that gives us y equals negative 12. So I extended my y-axis a little bit at the bottom of the page there so that I could graph all the way down to negative 12 on the y-axis. Now I've got 2 points, an x-intercept and a y-intercept, and so I can connect the dots with a straight line. That's our final answer. Problem 26 asks the same thing as problem 25 does. We need to graph the equation negative 2x plus 7y equals 14, and we'll use the same method. We'll find the x-intercept first and then the y-intercept. To find the x-intercept, we plug in 0 for y. 7 times 0 is just 0, so that simplifies our equation to negative 2x equals 14. Divide both sides by negative 2, and that gives us x is equal to negative 7. So there's our x-intercept. Now we'll do the same thing for the y-intercept, and that's when x is equal to 0. So we'll plug in 0 for x. Negative 2 times 0 is just 0, so that simplifies our equation to 7y is equal to 14. Divide both sides by 7, and that gives us y is equal to 2. Now that we've got our x-intercept and our y-intercept, we can connect the dots with a line, and that's our final answer. Graphing an inequality like on number 27, it is slightly more complex than graphing an equation. The only difference is that we have to consider whether we want to use a dotted line or a solid line, and then we have to consider shading. We'll still graph the intercepts first, then determine what type of line we want to use, then determine what side to shade. So we'll start with finding the x-intercept, which means I'm going to plug in 0 for y. When you're finding the intercepts, the inequality symbol doesn't matter, so we can just put an equal sign in between both sides of the inequality. So negative 3 times 0 just gives me 0, so I end up with x is equal to 9. That gives me my x-intercept. Now I'll find the y-intercept, which is when x is equal to 0. So I plug in 0 for x and simplify that equation. That gives me negative 3y equals 9. Divide both sides by negative 3, and I get negative 3 as a result. So my y-intercept is negative 3. Now I want to figure out what type of line. In this case, there's no line under the inequality sign, so I would use a dotted line to graph this. Now I want to figure out what side of that line has all the points that when I plug them into the rule, it gives me something less than 9. Using a test point will help you figure that out. I usually use the test point 0, 0. The only time you can't use that point is if the line goes through it, but this line does not go through the point 0, 0, so that's an okay point to choose. I'm going to plug in 0 for x and plug in 0 for y. Simplify that expression, and it gives me that 0 is less than 9, which is a true statement. So the side of my line that I have graphed that contains 0, 0 is going to be the side that I shade. Problem 28, we're supposed to graph the inequality 5x plus 2y is greater than or equal to 20. We'll start by finding the intercepts. Find the x-intercept by plugging in 0 for y. That gives us the simplified equation of 5x is equal to 20. Divide both sides by 5, and that gives us x is equal to 4. So that's our x-intercept. Now we'll find the y-intercept when x is equal to 0. Plug in 0 for x, and that gives us the simplified equation 2y equals 20. Divide both sides by 20, and that gives us y equals 10. Now we've got our 2 points. We need to figure out what type of line to use. This time there is a line under the inequality symbol, so we're going to connect these dots with a solid line. Now we need to figure out what side to shade, and again I'm going to use 0, 0 for my test point. So I plug in 0 for x and 0 for y, and that gives me a statement that says 0 is greater than or equal to 20, which is false. So I'm not going to shade the side of the line that has 0, 0. I'm going to shade the other side. Problem 29, we're supposed to graph the system of inequalities. It's the same as graphing individual inequalities. We just have to look at where the shaded regions overlap in order to get our final solution region. So I'm going to start by graphing the inequality x plus 2y is less than 8. I'll find the x-intercept first by letting y equal 0. When I plug in 0 for y, I end up with x is equal to 8. And so that gives me my x-intercept. Now I'm going to find the y-intercept by putting in 0 for x. That gives me the simplified equation of 2y is equal to 8. Divide both sides by 2, and that gives me y is equal to 4. So positive 4 is my y-axis intercept. Now I need to determine what type of line to use. There's no line under the inequality sign, so I'll use a dotted line. Then I need to figure out what side to shade. Again, I'm going to use 0, 0 for my test point. When I plug that into the inequality, I get a statement that reads 0 is less than 8, which is true. So I'm going to shade the side that includes 0, 0, because that gave me a true statement. Now I want to repeat that entire process for the second inequality. 5x minus y is greater than 10. I'm going to find the x-intercept first by plugging in 0 for y. I get a result of positive 2. And so I'll graph that on the x-axis. Now I want to find the y-intercept by letting x equal 0. And that gives me a value of y equals negative 10. So I'll graph that on the y-axis. Now I need to determine what type of line to use. No line under the inequality sign, so I need a dotted line. And then last I figure out what side to shade. I'm going to use 0, 0 as my test point again. I'll plug in 0 for x and 0 for y, and that gives me a false statement. It says 0 is greater than 10, which is not true. So for that dotted line, I want to shade the side that does not include 0, 0. And where the yellow and the purple regions overlap, that's the solution region to the whole system. Problem 30, we're supposed to graph another system of inequalities. So we want to do the same thing as we did on 29. We want to graph each inequality, finding the intercepts, determining what type of line to use, and figuring out what side to shade. So I'm going to start with the top inequality and find the x-intercept first. I'm going to plug in 0 for y. And when I solve for x, that gives me x is equal to 3. Now I'm going to find the y-intercept by plugging in 0 for x. When I solve for y, that gives me y is equal to 4. Now I've got 2 points that I can connect. I need to figure out what type of line to use by looking at my symbol. This one's going to take a solid line because there's a line underneath the inequality symbol. And now I want to figure out where to shade. I'm going to use 0, 0 as my test point. I'll plug in 0 for x and 0 for y, and that gives me a statement that says 0 is less than or equal to 12, which is true. So I would shade the side that contains the point 0, 0. Now I'm going to repeat that whole process for the other inequality. I'm going to start by finding the x-intercept and plugging in 0 for y. When I solve that for x, I end up with negative 9. So that's my x-intercept. Now I'm going to find the y-intercept by plugging in 0 for x. When I solve for y, that gives me positive 3. So that's my y-intercept. I need to figure out what type of line to use. This one will take a dotted line because there's no line underneath the inequality symbol. And then I need to figure out what side to shade using a test point. I'm going to use 0, 0 as my test point again. So I'll plug in 0 for x and 0 for y, and that gives me a statement that reads 0 is greater than 9, which is not true. So for the dotted line that I just drew, I want to shade the side of that line that does not include the point 0, 0. The solution region is where those two colored areas overlap.